Well, now, notations and definitions and all kinds of fancy stuff. A or B refers to something called the union of two events. There's a word for it, A or B. Since it's used so often and it's real particular with its rules, we gave it a name. It's the union of two events. And it also means, in probability and statistics, A or B or both. And here's the notation for it. Instead of writing out the word or, we actually have a notation for union, and it's like a big fat U for union. A union B means A or B. Definition: A and B, not or, but A and B, like the guys with the pierced ears. That refers to the intersection. Write it small. I didn't leave you a lot of room here. That's the intersection of two events. It means the event that both A and B happen. Now, it's denoted with this. There's an A, and then we flip the union thing upside down for the intersection. Okay, so this is about the word or in probability, and this is about the word and. So this would come up as probability of A or B, like rolling a 3 or a 5. And this is the probability of A and B, like what's the probability that you pick a guy and he has pierced ears. So you're going to get tired of seeing this because this is good enough, even though, man, I wrote that really badly. Even though I wrote it badly, this is good enough for you. So this is going to bother you that there's another notation, but I'm going to write it because it shows up on the AP exam and it shows up in different books, so you should see it. The probability of A or B is equal to the probability of A plus the probability of B. I'm writing what we already have, minus the probability of A and B. I just wrote it better this time than I did at the top. It can also be written in a different way, and it would look like this. Ready? The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Those two things mean the same thing. I'm probably going to use the words or and as often as possible. This may show up sometime, and it certainly could show up on the AP exam. Okay, on page 321, we're going to talk about Facebook versus Instagram. This is getting a little outdated already, and this book's not that old, but a survey of all residents in large apartment complex reveals 68% of them use Facebook, 28% of them use Instagram, and 25% do both. You guys, this is just like guys, yes or no, and pierced ears, yes or no, isn't it? There were guys with pierced ears, there were people who had pierced ears. Suppose we select a resident at random. What's the probability the person uses Facebook or Instagram? Well, you got 3 ways now that you can answer that. Facebook or Instagram is the probability of Facebook plus the probability of Instagram, but I just counted people twice, so I subtract off the people who use both Facebook and Instagram. That's what they're going to do here. So watch. Facebook versus Instagram. They're going to go probability of Facebook. There's the 0.68 for 68%. Probability of Instagram, there's the 0.28 for 28%, but I just counted people twice. If they happen to use both, I just counted them twice, and so that's too big, so I got to subtract off the probability of both so that those people are only counted once. And so add these two, subtract the intersection, you get 0.71. I want to show you something different. Okay, this example, Facebook versus Instagram, I'm going to show you 2 different ways you could do this. I'm going to do a 2-way table. Okay, Facebook is going to have yes or no people, and then Instagram is going to have yes or no people. Okay, I'm going to make a 2-way table out of it. I'll just use the percentages as decimals. All right, Facebook, it said 68% of people use Facebook. So where Facebook is, I go to yes, and I go, this is going to be 68%. And that's going to add up to 1 for 100%. Instagram, 28% of people use Instagram. So I go to Instagram and yes, and I go down here and I put a 28. Now I wouldn't be able to fill in anything else if they didn't give me any of the numbers, but they did give me another number. 25% use both. So that's a yes for Instagram and a yes for Facebook. That's a 25 right there. Can't you tell me what that number is? Can't you tell me what that number is? And can't we fill in more things? Okay, so this is going to be a 0.03. This is going to be a 0.43, I think. Did I do that right? 68, good. Can I do anything else here? Yeah, of course I can. This is going to be a 0.72. That makes 100. This is going to be a 0.32. And so both ways I go here, this is going to be a point, is it 29? Did I do that right? 29, 60, 72, 29, 32. Yep, I did it. So then I could answer any question now that I have the two-way table. The probability is, what's the probability they use Facebook or Instagram? Well, that would be this 25 for both. This 3 for Instagram, yes, Facebook, no. And this 43 for Facebook, yes, Instagram, no. If you add these 3 up, you would get the answer that they got by adding and subtracting. Of course, the other way you could do that is with the stupid Venn diagram. Right? This is Facebook. This is Instagram. But I need you to see something. When you do, this is why I hate these things. When I do the middle is going to be 25%. I'm going to put 25 right there. You would be making a giant mistake if you went Facebook, yes, to 68 and put a 68 right there. You can't. This whole circle has to add up to 68. If you're going to use a Venn diagram, this whole circle has to add up to 68. So I've got to go 68 minus this 25. And you can see what that is right here. 68 minus this 25 is 43. You actually have to do some subtracting so that these two pieces of the Facebook circle add up to 68. Okay, Instagram, we're told Instagram is 28. Well, there's 25, and this has to add up to 28, so this has got to be the 0.03. Right? This is the reason right here that I don't like using the Venn diagram, because people put a circle and they see Facebook is 68 and they plop a 68 right in there, and immediately everything's wrong. Now this part out here, this is the part of, these are people who don't use Facebook and they don't use Instagram either. So I can add these 3 things up, like I was just saying, add these 3 things up over here, and I could get the probability of OR. Then what I could do is subtract that from 1 and get the probability that they don't do either one. Now since I already see what that is, I can just put it out here. Okay? There's a check your understanding. Go to page 321. They give you a two-way table and you're going to answer some questions. Do that now.